Hey, I have a question on. I was trying to find out the pH as equivalence point, but I was not sure how to set up an ice table for it. Can you help me do it?
Alright, so let me see. You have you have to calculate pH at equivalence point when you have 25 mils of 0.1 molar NH3
Yeah.
titrated with 0.1 milliliters, 0.1 molar HCl. Alright, so let me see if you can find the NH4 concentration first after these two have reacted.
Okay. So if I react NH3 with HCl, I would get NH4 plus H2O. Oh no. Yeah. And I would just get NH4 plus. And I have the concentration as 2.5 millimolars of NH3, but I don't have the volume for HCl. So what can I do is the mole to mole ratio is 1:1 for this thing. So I would have 2.5 millimolars of HCl to get 2.5 millimolars of NH4 plus.
Alright. So till now what you've done is you've actually reached the equivalence point, right? Because everything has been neutralized.
Yeah.
So, alright.
But what would be the volume of the concentration of NH4 plus at the equivalence point? That I'm confused about. Is that 25 mLs?
Okay. So the thing is, the best way you can do this is by thinking about you're doing it in a lab. So you have 25 mils of this, right? So in order to find the final volume of NH4, you would actually need to find the volume of HCl first.
Oh yeah. So I don't have it. But I do have the concentration of HCl, so that is 0.1 m. So that means 25 mLs of HCl as well?
Yes, I like how quick you did the math right now.
Okay.
Yes, but that's absolutely correct. And yes, that would mean that NH4 would have a total of
50. So that means my concentration would be divided by 50. In order to get that, that would be 0.05 molar.
Yeah. That's because, as you can see, so you're using m moles by mLs.
Oh yeah. Wouldn't that be millimolars? So I would cut down the milliliters, and that would be moles remaining.
Yes. You actually did the math in a really shortcut method. I think it's a really useful tool to do that to actually cancel out the milliliters. That is a really good method to do that.
So can you set up an ice table and do the whatever you know?
Okay. So since now I'm confident that I have the concentration to be 0.05. So if I have 0.05 of that, and since I know that this is not supposed to be a strong acid, right?
Yeah.
Because we are given a Ka value that's really less.
Okay, yeah. You got that right.
Alright. So I'm guessing that we need to use this up to make equal amounts of this one. Okay, so if I set up an equilibrium expression for that, I would think I would do NH3 and H3O and NH4. Okay.
Yeah, you're going the right way.
Okay, so I would need to use x times x divided by 0.05, and after I use that, it's much, and then 5.
You can, if you're done with this, then you can just do it here as well. So do this. And yeah.
Okay, I'll just simplify this. 0.05 and times 5.6 to 10 to the power minus 10 equals x squared. Okay, so I would need to use quadratic formula for this, right?
Oh, do you think you need to do that? Are you aware of the shortcut that you can use?
I think, oh yes, because, okay, so right now I can see that k is so small,
Yeah.
even if I multiply by 100, yeah, that's the one, right?
Yeah.
Okay, so, okay, that makes sense because 0.05 minus really small numbers doesn't
Yeah.
make much of a difference.
Mhm.
Okay, so that,
Yeah.
and I never got to use it in a problem, so that makes a lot of sense. 0.05 times 5.6 into 10 to the power minus 10. So to find x, I can just root it, right?
Yeah, the square
Okay.
is perfectly fine.
Okay, I'll just try that. Okay. 5 point 29 into 10 to the power minus 5, and that is in motors, right?
Yeah.
Okay, so I can actually use that and get minus log of that to find pH, right?
Oh yeah, that's
Okay.
the way you do it.
Okay, so yeah, I'm pretty confident about the shortcut rule as well now. Thank you very
Yeah.
much.
You're welcome.